B cells with receptors specific for peripheral autoantigens are held in check by a variety of mechanisms. During B cell development in the bone marrow, B cell antigen receptors specific for self molecules are produced as a consequence of the random generation of the repertoire. If a self molecule is expressed in the bone marrow in an appropriate form, clonal deletion and receptor editing can remove all of these self-reactive B cells while they are still immature. There are, however, many self-molecules available only in the periphery whose expression is restricted to particular organs. An example is thyroglobulin, the precursor of thyroxine, which is expressed only in the thyroid and at extremely low levels in plasma. Backup mechanisms exist to ensure that B cells reactive to these self-molecules do not cause autoimmune disease. When a mature B cell in the periphery encounters self-molecules that bind its receptor, 4 proposed mechanisms could bring about the observed non-reactivity. Failure of any one of these mechanisms could lead to autoimmunity. First, B cells that recognize a self-antigen arrest their migration in the T cell zone of peripheral lymphoid tissues, just like B cells that bind a foreign antigen. However, in contrast to the response to foreign antigens in which activated effector CD4 T cells are present, B cells binding self-antigens will not be able to interact with helper CD4 T cells because normally no such cells exist for self-antigens. This lack of interaction prevents the B cells from migrating out of the T cell zones into the follicles. Instead, the trapped self-reactive B cells undergo apoptosis. A second mechanism is the induction of B cell anergy, which is associated with downregulation of surface immunoglobulin M expression and partial inhibition of the linked signaling pathways. B cell anergy can be induced by exposure to soluble circulating antigen. If mice are inoculated intravenously with protein solutions from which all protein aggregates have been rigorously removed to eliminate multivalent complexes, the peripheral B cells that bind these proteins can be inactivated. The lifespan of anergic B cells is short, as they are usually eliminated after failing to enter the primary lymphoid follicles or after interacting with antigen-specific T cells. This form of B cell tolerance can therefore be viewed as a form of delayed B cell deletion, with a significant difference that there may be autoimmune diseases such as SLE in which anergic cells can be rescued. The third mechanism depends on the presence of T cells that are specific for the self-antigen and express FAS ligand. In the rare instances when such an autoreactive T cell matures and is activated, it is able to kill autoreactive anergic B cells in an FAS-dependent manner. In the absence of the normal pathways of co-stimulation, energized B lymphocytes that have been chronically exposed to self-antigen show enhanced sensitivity to apoptosis after ligation of FAS by FAS ligand. They are therefore not subject to the stimulatory signals that oppose apoptosis in B cells whose surface receptors have just been ligated by foreign antigen. The importance of this mechanism is nicely illustrated by the consequences of mutation in the genes for FAS or FAS ligand. Mice deficient in FAS or FAS ligand develop severe autoimmune disease similar to SLE associated with the production of a similar spectrum of autoantibodies. Finally, there is evidence for a distinct mechanism for dealing with B cells that develop self-reactive specificities as a result of somatic hypermutation during a response to a foreign antigen. At a crucial phase at the height of the germinal center reaction, an encounter with a large dose of soluble antigen causes a wave of apoptosis in germinal center B cells, within a few hours. Thus, B cells can become reactive for abundant soluble self-antigens and could be removed. All these mechanisms re-emphasize the fact that the mere existence in the body of some B lymphocytes with receptor specificities directed against self is not in itself harmful. Before an immune response can be initiated, they need to receive effective help. The B cell receptors must be ligated, and their intracellular signaling machinery must be set to respond normally. And that's B cells with receptors specific for peripheral autoantigens are held in check by a variety of mechanisms. Have a great day.